Morning, everyone. This is the first session after the keynote. Most of this is going to be demo, but I'm going to talk a little bit about GitHub first. So the session you're in is end-to-end DevOps with GitHub, right? So we'll take a step back first and talk about what DevOps is. By this point, I'm hoping everybody knows what DevOps is, or at least has their own idea of what DevOps is. You've undoubtedly seen that kind of infinity symbol. There's a few displays of it outside in some of the sponsor booths where we talk about planning our work and then building and testing and then deploying and shipping it out to production. So by the way, I'm going to do this like this because I'm really worried about if I change stuff. PowerPoint goes to presenter mode and that broke it last time, so thanks everyone. So you've probably seen this, right? Idea, build, ship, go to production, and then learn from what's in production. And the ultimate aim of DevOps is just to get through this cycle as quickly as possible, but as safely as possible, right? There's no point pushing things out to production if every single time you do it, it breaks. So the idea is to get it out the door as quickly as possible, right? Why, though? I mean, I've certainly worked in a whole bunch of companies where you do a release every 6 months or every 3 months or something like that, and it goes horribly, that's fine, because you've got 300 features that you're trying to push into this one release, and they don't play nicely together, no matter how much you've tested them. But you only have to do it every 3 months, right? And then, you ship it on a Friday afternoon, and everybody comes in on the weekend, and you have pizza, and it's great fun. So why isn't that a good thing? Well, generally, the faster you can do this stuff, and the safer you can do this stuff, the more frequently you can push real features, real valuable features out to customers. But a little bit beyond that, you can push these features out to customers and judge whether they are valuable more frequently. Like there's a big difference in an organization between saying, that feature I just worked on for the last 6 months? Turns out the customers don't actually want that at all. That's a job-ending conversation, right? It's very different to be able to say that than to say, that feature that we've just started working on, we put out a really early prototype and made it available to this customer who's really nice to us and they're happy to try these things for us. And they thought we're going in the wrong direction, so we're going to just pull it back and we'll work on it a bit more and work out whether it is actually valuable. Like, you've wasted a much, much shorter period of time. It's much cheaper to change direction as early as possible. So if you can get that feature out the door in a few days, few weeks, even up to a month or something like that, you can get a much better idea of whether it's going to work for your customers and whether it's valuable. And the data supports this, right? You've probably seen a ton of slides that look like this, potentially, with all of these trusted sources of information claiming that high-performing software engineering teams produce much faster code into production. They reduce the number of errors that you're introducing and they can fix those errors more quickly, right? This one's from McKinsey, which is on the scale of GitHub's Octoverse thing up to the New York Times report. It's somewhere up towards the top. So this is a good one to send to your managers. But elite software organizations, they kind of define as these organizations that can release code up to 200 times more frequently. They have 7 times fewer failures when they hit production, because their pipelines are quite mature. They know that what's going into production has been adequately tested. They can do that much safer. But other things like they can set up dev environments. The onboarding for a new developer is 100 times faster than it was at other organizations. I don't know if this is true for you, but back 20-something years ago when I first joined my first real company as a software engineer, I went 2 weeks without being able to cut any code because they needed to get me a machine, to provision that machine, and then also to get the right dependencies on that machine, and then work out why I didn't have the right permissions on my account and all that sort of stuff, right? So I read documents for 2 weeks. Didn't really align with what I thought a software developer would have to do, but it's changed a bit. But there's also things like internal communities of practice, so lots more teams across the org working together, and integrated security. So not a separate security team making sure that things are secure, but an integrated one alongside your developers, developer-focused, that's kind of making sure a lot of that stuff is correct on the way through your software delivery lifecycle. The other report that I keep referring to and have done for ages, is the State of DevOps report, and it highlights that high-performing DevOps teams have 200 times more frequent code deployments. There's a faster commit to production lead time. Internally at GitHub, we actually have a measure called L2D, I think it is. I2D, idea to deployment, idea to data. So even further. So how long does it take us from an idea of a feature to implement to getting data about whether it's actually being valuable to customers in production? And that's the metric that we care about. Like, how quickly can we get from an idea to knowing whether it is a valuable idea? And then when things go wrong, because they will go wrong, doesn't matter how good your pipeline is, how quickly can you recover? Like 2,500 times faster if you're a high-performing DevOps team. Now, the thing that these two graphs don't really show, although the previous one I think had a 4 to 5 times higher revenue growth, a number down the bottom. The thing that these typically don't show is that there is a strong correlation between the maturity of your DevOps practices in your software teams and the success of the business according to their own metrics. So we're not talking about pure how fast can you get code out the door. We're talking about how successful is that business at meeting their own business goals. There are correlations between this and how happy the staff are, right? Staff turnover has a direct correlation to how mature DevOps processes are. And this is not somebody just saying it makes sense because everybody's happier because they can do stuff. There's real data behind this. Researchers like Nicole Forsgren have come up with a ton of this information that's freely available. You can download it. You can also buy their books and read that stuff. But there's real research data behind this that shows that is a real correlation that exists. In the keynote, Richard Campbell kind of touched on this as well. He was saying that software engineers, software teams in companies have a direct relationship to how successful that company is. His point about know how your company makes money, because then you can work out how your team fits into it, that ties into DevOps as well, right? The better you are at delivering software, no matter whether you're delivering it to customers or whether you're delivering it to internal teams, you have a direct relationship to how successful that company is at their own metrics. So hopefully by now everyone's like, okay, cool, can you sell me a DevOps, please? Not really how it works. So if we go back to this cycle that we keep seeing around starting with an idea, building that idea and shipping that idea and getting it out the door, trying to do it as quickly as possible. One of the things that GitHub has been trying to do over the last handful of years is work on most of this to make it as streamlined and as quick as possible. There have been huge improvements, especially around the building phase, and I'll show you a bit of Codespaces later on. The cycle time and the inner loop of actually doing that development is getting better and better, faster and faster, which is great. Shipping with GitHub Actions, and then the idea generation and feedback from customers and things like that with GitHub issues and projects, and discussions and things like that as well. We've been working on that. We have a few aims at GitHub, one of which is to try and create this set of collaborative automated workflows with GitHub Actions. So trying to make this stuff as automated as possible. And these workflows aren't just committed code into production. They're also things like somebody's come up with an idea, let's triage that appropriately and manage it appropriately with an automated workflow. So there's a lot more than just CI/CD there. Having that security focus, a developer focus, so you don't have to have separate security teams to cover a lot of that. I'm not saying you shouldn't have separate security teams, but a lot of the obvious things, known dependency, vulnerabilities and things like that can be covered. And then ultimately just having this fully integrated platform from idea all the way through to running in production. So today, we're going to look at these three parts of GitHub, and we're going to touch on a couple of others. I think it'd be remiss of me to do this without trying to use Copilot. Now, Copilot is that AI pair programmer that Richard Campbell mentioned in his keynote as well. It went GA today, so generally available today, which means that the billing has changed, which means that the feature flag that I have turned on for myself that turns off billing may have changed. So when I start to use Copilot, there's a legitimate chance it'll not let me use it until I enable my new flag. So we'll try, and we'll see how that goes. But we're going to look at GitHub issues, which includes a new projects system. We're going to look at Codespaces for quickly getting running and quickly coding in that cycle. And then we're going to look at GitHub Actions for doing our automation from CI/CD perspective. Cool. That's the end of the slides. I just want to show you this stuff, right? I could do slides with screenshots, that's great, but we're actually going to get something that looks like a bit more of a real project. And we're going to go through this cycle to show you everything that's available. Any questions before we start? No. Excellent. Everybody is on board and everybody is going to do DevOps really well. Now, where is my browser? Nope. Of course, over here. All right. I'm going to zoom in a bit. Occasionally, I'm going to zoom out a little bit because mobile first, we kind of rearrange things. I want to show you the screens that we've got. This is my application, right? It is a .NET web application, probably an older framework. I haven't updated the code for a little while. But we are going to start with issues. We're going to start with gathering an idea. I just want to show you what that application looks like, though. If I can remember what it is, Azure Websites.net. Oh, it's going to be good. I'm going to have to look at the actions to find out what it is. It's a really basic application. We'll debug it in Codespaces and you'll see it. So we have our collection of issues that people have gathered in our Issues tab. We've pinned one up the front, at the top as well, so you can pin up to 3 of these issues to make them, to draw attention to them. It's worth mentioning as well that the meaning of the word issues is a bit overloaded. Issue has a bit of a negative connotation, like a synonym for bug. Issue in GitHub language is a thing that you need to talk about or track. Right? It's a piece of work or even just a discussion or a piece of information. It's an issue in terms of like, we were talking about this issue the other day, right? So good thing to get your head around. It's not just a bug. So we've got a bunch of these in there. We can obviously create a new issue. And this is quite a rich UI now. So our title might be something like change background color. Spelt correctly because we're in Australia. And you can get like real rich text in here. So this is just Markdown. I can do a heading here. And I can even do things like a screenshot. So I'll just grab part of that screen. It is showing you that. Great. And paste it in. Oop. Oh, yeah, I'm on a Mac. Hold on. Hold on. I know how to do things. Give me a sec. Control, Shift, Control, thing, B. Who would have thought the screenshot would be my problem? And so it uploads that image to cloud storage. And then in our preview, we can see screenshots. So we can paste this in. We can paste in videos. We can add videos and GIFs and all sorts of stuff. We can even do other things like having task lists. So a task list, if you want to break down the task that you're doing, so changing background color might be change CSS, and then, I don't know, change back, colors set in docs or something like that. And so we can do all that work. We can also do deep links to the rest of GitHub. So one of the advantages of using GitHub kind of end-to-end is you get this linkage, these deep links all the way through the product. So if I wanted to mention another issue, like this is related to that pull request that somebody did to change it back to someone else in a previous demo perhaps, we have that link to another issue, and that will allow me to kind of follow that path through. We can also @ people, so our individuals in here, that's @ not me. And when we submit that issue, we kind of get that rich detail about what's going on. We can get deep links to that person, to that issue, and then if I'm logged in as me, I will end up getting alerts for that and get told that there's something that I've been mentioned in and so on. There's also this whole conversation that happens. So not just the original issue, but we have a conversation about it. Different people can comment, they can link to other pieces of code. You can also link to commits. You can link to other repos, and it will unfurl those if you've got permission to. We can do the usual things like assigning myself to this. We can set up some labels. This is like an improvement, an enhancement. And then there's a whole bunch of stuff. We can create a branch directly for an issue as well, so we can start working on it, do pull requests and so on. All this stuff is in there, and you'll see we get that history of what's happened. Cool, right, that's a single issue. Great for tracking a single piece of work, but maybe not so great for planning. So planning, we come to projects. Now, projects has been written again from the ground up. The previous version of projects, the legacy one, is still there for the moment. There is a migration tool, though. So if you're using the old versions of the projects, you can just migrate to the new one. And you definitely want to, right? The new one is insanely flexible. We're going to add a brand new project. One thing to note is that the projects are not repository specific. The projects are organization specific. And the reason is a lot of companies have multiple repos for a single product, right? You don't want to have a backlog for the database microservice or the data microservice that you have over here and a separate backlog for the front end and things like that. So you can bring in issues and pull requests and things from multiple repos in your organization. It's just better for organizing. So we're going to create a new project. We'll call it .NET Web. There's a few templates we can start with too, so we could also just do a team backlog and it will format everything that way. We're just going to do a standard table. We're going to call it NDC Melbourne. And let's just do a product backlog. So we'll call this backlog. Now to add them, we just hit hash, same as the other ones. But because we can pull it from multiple repos, we've got to choose the repo we're going to add it from. And then it'll give us our list of issues and pull requests. So issues and pull requests share an ID incrementing scheme. So an issue and a pull request can be referenced here as well. So let's just add a few of these. The keyboard navigation is pretty good these days. We've just released a bunch of things to improve accessibility as well. There are a couple of gaps there with keyboards and screen readers, but we've improved a lot of that. Let's just leave it at those three for the moment. We can also do a lot of formatting of how this looks. So let's just put in all these as to do. We've got our assignees. Let's add our labels. Not a link to pull request, our labels. So we can see that as well. I'm just going to zoom out one. Can everybody still read it at the back? All good? So we've got all this sort of stuff. We can also do draft issues. So if we just want to track some information, like what's a draft issue? Randomize saying. And that'll make sense when you've seen the application. So this is not an issue. It doesn't exist in the issues list anywhere. It's just a piece of information that we want to track, which is really handy if you have work that you want to track that is not related to code or related to a repository. We do this internally in the DevRel org a lot. So we have a social media kind of content backlog, and we don't need an issue for all of those. We just have a piece of information. So we just have a ton of these draft issues. We can still do things like assign that draft issue to someone. Even though it's not an issue, we can set a status. What we can't do is things like add labels, because a label is a native part of an issue. The other thing that's really handy here is custom fields. So if we wanted to add like an estimate field that's a number, we can do that. And then have like 5, 3, 6. They're random because real estimates are random anyway. We can also go a bit further and have a new field for our sprint or our iteration. Now this was originally, fun fact, originally not going to be a first-class citizen of projects. We weren't going to do issues. We were going to let you handle that yourself with your own drop-downs and things. But after speaking to customers, we worked out that everybody does some kind of iteration strategy, whether it's milestones or sprints or whatever, or a lot of people do. So now sprint is a type. So by creating that field, it's actually populated a number of sprints. And we can change those sprint dates. We can change what they're called. So if we just let's just put everything except that last one in sprint run. And there you go. I think that's a pretty good backlog. So let's just save the changes. And I'll show you the other view, which is really handy as well, which is the board view. So this is handy for your sprint backlog. You can use things like the command palette, which is Control K or Command K, and say we want to filter by sprint and do it with the current sprint, so it'll only give us the current sprint. We could change what we see in those cards. So at the moment it's titles, assignees, and status, but we probably want labels and an estimate. So we have that information now. We can, of course, kind of drag these around the same way we would. And so people quite often will do a product backlog and they'll have a sprint board. And then they can also have their own personal backlog, which is just the things that have been assigned to them that are in the current sprint. So the grouping, filtering, all that sort of stuff is in there as well, as you'd expect. There are a couple other things you can do. So there is a bit of automation with workflows. Sorry, I'll just save this. A little bit of automation that you can do with workflows. There's more coming. But at the moment, the project itself is a bit separate from the issues in a repository, because the project is at an organization level. The issue in the repository is at the repository level. So you may have a single issue in multiple projects, which means that if you drag it to done in one project, maybe it's not done in another project. We're kind of leaving that a bit up to you, but there is some automation to do things like, when we close an issue, then just put it in the done column in your projects, any projects that it's related to. There's some more of these that are standard ones, like if you add an item to a project board, it will set the status of that issue to to-do and things like that. But if I just zoom out one more time, there's a whole bunch of other ones coming soon and some customizable ones. And if what you need is not available here, then GitHub Actions can talk to projects and issues as well. So you could say something like, which we do, when somebody creates an issue in a repository, if it has this particular label assigned to it, then add it to this project board and give it this status and assign it to this person. So you can do all that kind of automation as well as the CI/CD stuff. One thing that's also not going to be available for you, I've flagged myself in, is the idea of these charts, these burn down charts. You can create your own charts with whatever information you want. So, a bar chart, which is the, the per assignee, and then grouping by, doing a sum of the estimate field, and it will show you how that has progressed, or what that looks like for each person and things like that. So those graphs, the general idea is that we want them to be live things that you can embed in other Markdown formats. We're still working out what this actually looks like and how it's going to be the most useful for people, but there is some of that insight stuff coming too, which is pretty handy. So there's a lot in project boards. We use this internally for everything, right? We use it for managing the events that we're going to. There's an in real life repository that we use to track the issues that match conferences that GitHub is going to sponsor and attend. And we use project boards. There's no code behind that. We just use the boards to manage it. And then, of course, for GitHub itself, we have project boards for everything that we do internally with teams, and then even epics and across the board. In fact, let me just get my bookmarks back. I'll show you, we have a public roadmap. It's going to ask me sign on. Sorry, give me a sec. Oh, that was quick. So this is our public roadmap. So everybody can see this, we've made this public, and it tells you in what quarter certain issues are going to be released. You can also do things like if you care about what things are GA, this is the rough timeline. And these are actually issues too, so if you click into them, you can get a whole lot of information about what's actually happening. It's shipped, and there's the blog post about it. Ooh. I clicked it, did I? Good. So tons and tons of stuff in the projects. Before I move on, because I want to move on to the next bit, any questions about what projects can and can't do? This is, by the way, free for everybody. There's no charge for any of this. You can just do it. All good? All right. Let me just go back a few pages. We saw before when I was in that project, the .NET Web, repository, that I was linked out to the organization. Adding a project is really just establishing a link in your project, sorry, in your repository to that organization level project. It's just a shortcut that exists. Okay, that's cool. One thing I wanted to do that I forgot to do in that project is turn that draft issue into an actual issue. So we had that draft, the draft task or the draft issue there. I want to turn that into a real one because I want to randomize that saying. So I'm going to convert it to an issue in the in that .NET Web repository. The other thing that I didn't show you as well is if we go to change background color, which is that one we did, and open that in a new tab, right up here, you can see that that is tracked with 2 tasks. That was our task list that we had down at the bottom. So we can see when I check one of those, one of 2 tasks is done. I could go further as well if I'm breaking down that task. I could say, well, I actually, sorry, just refresh. I actually want this to be an issue. So I'm going to convert that one to an issue. And now we have an issue and a hierarchical relationship between that top one and the other one. So if I go to that color set in docs, you can see it's tracked in issue number 20. So we have that relationship that's coming up. That's going to surface in a lot more places soon. Right at the moment, this is kind of as far as you get. But that relationship does exist. All right, cool. Well, let's do some work. Who here has used GitHub.dev or just the web-based editor, or who knows what it is? Just 2, 3, 4 hands. Great. That's awesome, because this is one of the things I use the most. I'm in my repository in that code window. I'm going to hit full stop or dot. And it's going to open a web editor for me, which, if you use VS Code, is going to look super familiar. This is VS Code running in the browser. This, again, is totally free for everybody. If you go to a GitHub repo, even one that you do not have access to, like write access to, you can do this. Just hit dot, and you get an editor. Now, it's not just a read-only editor. You can edit everything in here. It's everything that VS Code gives you with a couple of little, oops, sorry, let me just get rid of that bookmark. A couple of limitations. One is that everything is running in your browser, so there is no backend, which means there is no terminal. You can't run commands because there's nothing to run the command on. And you also don't have the ability to run and debug for the same reason. There's nothing to compile your code on, right? It's just running in the browser. Extensions are a bit hit and miss too. So if you use some linting extensions, for example, there's a whole bunch that are not available in, oh, that one's deprecated, wrong reason. Not available in Visual Studio Code for the web. And that's because it needs some kind of compute behind the scenes. But a lot of them are. A lot of them are here. So things that you might not expect. Live share, VS Code live share. So you can do pair programming in your browser without needing the code locally at all, with somebody on the other side of the world against the same code base. And neither of you have this code on your machine. It's pretty crazy. I have not actually used anything except for the web editor and Codespaces, which we'll look at in a sec, in about a year now. I have not cloned a repository to my local machine for a long time. So these limitations are there, but you can do a lot of work. As long as you don't need to compile and debug, you can still do a lot of work. So let's go down to one of the extensions that is installed in the web editor by default, which is this GitHub extension here. And we're going to say we're going to do this change background work. So we can click on that to view it in the web if we want to actually view that issue, or we can just start working on that issue. And the way I've set mine up is it's going to create a branch for me. So let's just call this change background. And that'll go to GitHub and it'll say I'm going to create a branch for this work that I'm doing. The context of the web editor will change, so now I'm working on that branch. And you can see down here, we are now in this branch instead of the main. And I can do that work. So what is it? Changing background. That'll be somewhere in a CSS thing. We get our background somewhere input type background. I'll find somewhere. It doesn't really matter actually what it looks like. But you can see like it's VS Code. Like it's got our color pickers, it's got all of our autocomplete, it's got all of that stuff running in here, which is pretty cool. All right, let's change that, make that change. We'll say changed background. We'll add that to stage changes, and we'll commit. Now the big difference here is because this is running on the web, and down in over here you can see we are working directly against GitHub. We're editing on GitHub, so there's no push. I've committed that, but it's committing it to GitHub. All right, so just be a little bit careful. When you commit, it's committing it to the repository. So there we go. We've done that in a branch. The next thing I want to do is a pull request. So that's the little pull request icon. Let's create a pull request. Yep, going to main, change background. I'm also going to say this fixes, was it 20? Let me just have a quick look. 20, yep. Oh, what did I do? GitHub pull request. Fixes 20, create, and now we have a pull request. Now, this screen that comes up now is awesome for reviewing pull requests. So we can see the conversation about the pull request, we can see the files that have changed, we can check out diffs. This screen is the exact same screen I will get if I go to the repository that I have and look at a pull request and hit dot. It'll bring it up in the context of that pull request so I can review really easily with that branch already set up in the web editor. So rather than clicking the tabs to look through the code and the changes and so on, you can just do it in VS Code. Just hit dot and it lets you review really nicely. Now this looks great, obviously, because I did it. It could be wrong as well. I just chose a random CSS background thing. So I can also do things like squash and merge or rebase and merge if you're into that. Squashing is probably my preferred. And you can also set up branch rules, so you can say pull requests can only squash, or they're not allowed to do merge commits. And this goes deep. All right. Looks great. Ship it. There we go, a little ship it squirrel. And then we can also say merge, squash and merge. And what's quite cool is now that we've merged that branch, we can, let's just click over here and say go to repository. Now that we've merged that branch, oh, I'm on the wrong one. Because I was in that branch and said go to repository, it's taken me back to the repository in that branch. We can look at that project that we had before and see in our sprint backlog that change background color has been closed for me. So we get that automation. Really kind of nice to get that end-to-end. Like we've done some work, we've picked it up. That issue as well, like if we look at it, is closed now because we did that work. And we get these deep links through to, that's the commit that I made. I mentioned that issue in that pull request. I can go to that pull request and drill down into the commit that I made and the code changes that I made and all that kind of stuff as well. So we get that traceability all the way. Now, I haven't left the browser. I haven't got Visual Studio Code installed locally. I haven't even cloned the repository locally. I think the local clone I have of this is about a year old. So I just haven't touched it. So let's do another piece of work, though, that needs us to do a bit more than just editing some CSS and not worrying about compiling. So a bit more real work. Let's go to issues, and then we'll choose this randomized saying issue. Now, I'm going to say create a branch. That's the way I tend to work. But this time, I want to actually debug. Now, we saw before that when you go to the run and debug, I'm not allowed to do that. And that's because there's no backend. And that's where Codespaces comes in. There's a few ways I can do Codespaces. If I say continue working on, I can create a new Codespace right from the web editor, if I want. Or I can go to the code tab in my repo and go to the code and over local or Codespaces. Now, I have one already set up. The reason I did that is for performance purposes, but it's not actually that different I can configure what size code space I want as well. So if I wanted to configure how big it's going to be, by default in my repo it's a 2-core one. Because we're in a demo and I don't have to pay for any of this, I'm going to do a 16-core one. We can also set up pre-builds. So while this is building, I just want to explain, pre-builds went generally available last week, on about the 15th, I think. Pre-builds allow you to pre-configure one of these code spaces that is already customized and optimized for your project and have a template of that ready to go. So when you create a new code space, I mean, it didn't take very long, right? When you create a code space, it can do it really quickly. Now, to put that in perspective, GitHub used to, before pre-builds, we used Codespaces as well. The GitHub repository, so whatever you see on github.com is a mono repo, for better or worse. There's about 11 gig of stuff in that repository. On disk, it works out to about 23 gig with the Git history. Creating a new code space before pre-builds took about 45 minutes. So we click new code space, go away and have lunch and come back. After we implemented pre-builds, so optimizing it and getting these templates, it was 10 seconds. So a new developer to GitHub can walk in, create a new code space, which is just theirs, just this development machine in the cloud, and be able to cut code, like real code, on a working machine in the cloud in 10 seconds. We've heard from other customers of ours who are using this that they've got their onboarding process down from 3 days to 5 minutes. So this is a real game changer if you are onboarding customers. The other thing that's worth mentioning is this is my code space in the context of my main branch. If I wanted to review someone's pull request and debug and walk through the application and things like that, I could create a code space against their branch. And it would spin everything up in the context of their branch, and I can work in that branch, say, yes, this looks good, approve the pull request, and then tear the whole thing down. Now, Codespaces is a paid product. You pay for it entirely. There is no free option at the moment. There are plans. We just don't know what it's going to look like exactly right at the moment. But if you work it out, it's about the same as buying somebody a new laptop every 2 years, in general. That's a very rough estimate, depending on the size and things like that. So now we have a code space. The big difference here is that we can debug. So we have our .NET Core launcher in this case. We also have a terminal, so we can do an ls. We are in the context of a machine on the cloud, so I still don't have this code locally. This is living in the cloud, right? But I can debug. So let's just press play and see that running. Oh, it's not going to run. Let me open my already done one, just to hopefully get through that issue. Come on. I must have removed some stuff. Good job. Let's see if it'll run in this one. If not, I can show you another one. Come on, debugger. Copilot. Great. So again, this is all running in the cloud. This is a machine that's running in the cloud. Nothing's local. .NET's going to take a minute to set up, so this may actually give me a 500 while it's trying to get a response that's not quite working. But I have a full VS Code debugging situation here. So port 5000 is open. Let's just do a bit of a refresh. Hey, and there's our application, right? We can debug too. So obviously, if we go to our, program.cs and say, I don't know, the startup. Actually, let's go to pages and then index, or the index.cs. and say, there we go. Let's debug it there. Refresh our page. Oh, there we go. It's because we've hit our breakpoint. And we can do everything that we would normally do in VS Code, right? So we can hover over our logger to work out what that is, look at the non-public members, expand all of that stuff. Exactly the same way we would normally kind of debug our application. The other thing we can do, which is quite cool, is we can expose that port, make that port visible to people in our organization, or even make it public. So while we're working, we could say to somebody, can you check out what I've done? Run it locally, and then let somebody else view what you've done, make changes live, and do all that sort of stuff, which is quite cool. This is also available in VS Code desktop. So you can use your desktop VS Code to talk to a code space. So you don't even need it locally. You have your internal desktop one, talks to a code space in the cloud, and does all of the compute up there. All right, cool. So that's all right. We will not worry about making this change because we're running short on time. But exactly the same thing would work. Like if we change to our branch, we do that work, we commit the branch, our issue moves across and we do all that kind of stuff. But then what happens, right? Well, after that, let me just stop this. After that, we want to kind of automate our deployment into production, right? And so GitHub Actions is the way we do that. Now, I had already set these up to save a bit of time, but we have a couple of changes here. So this changed background run here is a GitHub Actions run that triggered when I merged my changes back into that main branch. So I've defined a CI/CD workflow, and it has a number of stages. Our first stage is to build the application, and we can follow through all of our logs. We can do .NET build and see what all the logs look like. If you're watching this while it's running, these logs will just fill out. If you're familiar with Azure pipelines or something like that, you probably recognize what this looks like. It's the same kind of idea. The runners run in the clouds, they do the work for you, or you can run them on premises if you have your own machines. They will do the work, send the logs back, and you get these logs publishing to here. So you can watch it all happen, which is great. But what we've got in our summary is a stage where we deployed to our build. Sorry, we created our build. We deployed to a staging environment, and if we click on that link, we should hopefully be able to see if I've chosen the right background area. We should hopefully be able to see that it's going to spin up for the first time for a little while. Hopefully be able to see that changed. There we go. So we changed it to purple, which is great. That's what we want. Our production one, though, if we get rid of the staging bit, hasn't changed. It's waiting for me to approve that deployment to production. So to do that, I've got some policies in there to say I need to approve a deployment to my production environment. I can review it and say, great work as always. Approve and deploy that, and then it will just do that deployment to that production environment in exactly the same way. And yeah, we can watch that happen. So we can see when it picks it up, it's starting now, it's picked up a runner. Now these runners are self-hosted, or you can run them locally. When we do our deployments, we're doing them to environments, so we have this whole we can set all of these policies around when you can deploy to a particular environment. So if you have a look at our environments, we can see our staging one and our production one. Our production one has 2 protection rules on it. It's got to have a required reviewer, and we are only allowed to deploy from protected branches. So our main branch is protected. We have to go through a pull request process. That means somebody can't create a branch and then send it through that pipeline and get it into production. It has to be from our main branch. And we also have environment secrets. So secret information that's stored in a secured vault inside GitHub, so even we can't get that information out. They are write-only, and they are masked from any logs. So if you echo them in your agent or in your runner, it's not going to show up in your logs. That means we can set Azure publishing profiles, for example, for staging and production, and we can use the same steps to do the deployment, and it will just work. I could go into great depth about what these actions workflows actually look like, but I just did a 2-day workshop, and that took most of the second day, and we rushed through it then. But just to give you a rough idea, this is what that workflow file looks like. It's YAML, and it's beautiful despite what everybody thinks. And there's some great editor support and things both in the web and in VS Code. So you can write YAML with fewer mistakes. So 10, 12 mistakes per edit instead of the usual. Yeah. But that means once this pipeline's finished, which it has done now, our production is up to date. So we've gone through that whole process. And I want to highlight that. Our whole process started with me creating a draft issue. Well, in this case, I created a real issue, but I could have created a draft issue and turned that into a real issue, filled out some information, used the web editor or Codespaces to do that work, which tracked it back to the issue, which moved it across our project board, set up an automatic process for building and deploying, and then pushed it to staging, waited for approval to go to production. So we kind of got that entire end-to-end story. Now you can create an issue from a discussion as well. Discussions is this thing that is the kind of way for you to communicate with either your community or with internal organizations. And it's kind of, just think a forum, right? But from a discussion, you can create an issue. So create an issue from that discussion. So you could be having a conversation with your customers where somebody says, hey, it'd be really great if you could do this particular feature. Have a long conversation with product teams, with the rest of the community, set up a poll, make sure people can vote on whether they want it or not. And then at the end, just say create an issue from that. And then that flow goes all the way through to in production, and you get traceability from start to finish. So that's kind of what we're trying to aim for at GitHub. Everything from idea all the way through to production. Cool. I did a bit of a whirlwind through a lot of that. I'm around all week though. On Friday, I have another session on Codespaces specifically, if you'd like to know about that. I mentioned Copilot went GA. If you're interested in that, let me know, and I can show you what that looks like once I enable my flag. And there's so much more to GitHub if you want to check it out. Or if you want to argue about what DevOps means and what you should and shouldn't do, always up for an argument. But thank you so much. I'll be just outside for a little while if you have some questions. I know we're running pretty late and we've got a break. So appreciate your time. Thank you. Have a good conference.